Alright, hey everyone, Maia here. I'm picking up from my last video, which was on the multi-step absolute value equation. So now we're just going to talk about when you have less than, greater than, that sort of thing. Okay, so here's the key, and I'm going to give an example. So let's just start by talking about this. The absolute value of x is less than 5. So what does that even mean? Well, we know less than means obviously, well, less than. So the absolute value of x is less than 5 means that our solution x is going to include the numbers that are less than 5 units away from 0. Okay, so the solutions of absolute value of x is less than 5 are values between -5 and 5. So I'm going to illustrate that here with a little number line because it kind of helps drive the point home. Okay, so let's say this is where 0 is, right? And we want some value that is less than 5 units away. So in the positive direction, you've got things like 1, 2, 3, 4, right? Because those are less than 5 units away from 0. But then you've also got to consider the other side of the number line where we have things like -1, -2, -3, -4. Those are negative, but they are still less than 5 units away from 0, just in the opposite direction, right? From positive. So that means our solutions are going to encompass this area in the middle, this area between -5 and 5. So what we could do is we can consider, okay, also one thing, these are open circles. That means -5 and 5 are not part of the solution, because you can't say 5 is less than 5 or that the absolute value of -5 is less than 5. It equals 5. So it has to be this area in the middle, okay? So in other words, this is what we call a compound inequality. So that's what we're covering now, compound inequalities, okay? A compound inequality is like this, where we can write x is greater than -5, right? Because -4, -3, -2, that's greater than -5. And x is less than 5, right? So this defines our boundaries for this problem. X is greater than -5, but it's less than +5. So in other words, you can rewrite this as x is greater than -5 but less than 5, or -5 is less than x is less than 5, okay? That's how you can write the solution here. So we're going to have a solution that is less than 5 but more than -5. Alright, now let's check out another example. Clear up some, no, don't need to clear up space. It's a whole board, we can use this. Just going to draw kind of a border here so. Okay, so now for our first real example, because that was mostly just me explaining and talking. Okay, so I'm going to consider this as example 3 because like I said in the previous video, we're wrapping things up on absolute value equations now. So what we've got here, the absolute value of 2x minus 1 is less than 5. So what we're going to do is we're going to rewrite this using what we know about compound inequalities. So look at this. Remember, the absolute value of x is less than 5. We could write it as this. So what we can do is -5 is less than 2x minus 1 is less than 5. So now, to simplify, we're just going to isolate x. So adding 1 to all sides. I'm not saying both sides because there's 3 sides to this. So we get -4 is less than 2x is less than 6. And then divide each side by 2, and we get -2 is less than x is less than 3. So in order for the inequality to be satisfied, and for the quantity 2x minus 1 to have a distance less than 5, x must be between -2 and 3. So if we were going to illustrate this on a number line, you just do something similar. You'd have -2 over here, you'd have 3 over here, and then you'd shade in the area in the middle, because that is our range of solutions, right? So, yeah. Negative 1, 0, 1, 2. Yeah. You really want to get detailed on the labels. Okay. So this is with our number line or our number graph. This is what we call an AND problem, because you've got x is greater than negative 2 and x is less than 3. Let me repeat that just to make sure you get it clear. It's an AND problem because x is greater than negative 2 and x is less than 3. Okay, you put those together and that's why you get a compound, right? It's an AND problem, compound inequality. All right, so let's move on to another example. This one's a little different. This is going to be an OR inequality, okay? So we've just covered an AND inequality. Now let's talk about OR, okay? So it's a little different, but like a lot of things, it uses the same principles that we've been covering. Okay, so let's say we have something like this. The absolute value of 2x plus 4 is greater than or equal to 6. Now don't get freaked out because it has the equal part. It's still going to use a similar principle to solve. So what we're going to do, again, we're going to split this into two equations. 2x plus 4 is, now watch closely, 2x plus 4 is less than or equal to negative 6, or 2x plus 4 is greater than or equal to positive 6. Now why now? Look closely. We have the absolute value, and remember, we have to consider this just simply means the distance of 2x plus 4 has to be equal to 6 or more than 6. So hence we get these two equations. So what we're going to do is solve. So subtract 4 from both sides. This cancels out. 2x is less than or equal to negative 10. And then similarly, minus 4 from both sides over here. Well, we'll finish this first. 2x plus 4 is less than or equal to negative 6. Subtract 4 from both sides, and then divide both sides by 2. X is less than or equal to negative 5. And then 2x plus 4 is greater than or equal to 6 on the right-hand side. Subtract 4 from both sides. 2x is greater than or equal to positive 2. And then divide both sides by 2. X is greater than or equal to 1. Okay? So now, if we were going to graph this solution on a number line, this would mean, let's see, negative 6, 5, 4, 3, 2, 1, 2, 3. Okay, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. So, we're going to have x is greater than or equal to 1 in one direction. And then in the other direction, we're going to have x is less than or equal to negative 5. Now, we could just check, just to confirm the logic of this set of solutions, right? They don't connect. Therefore, it's an OR inequality. So let's see. Let's say I pick something like negative 6. Okay, let's try negative 6. So does the absolute value of 2 times negative 6 plus 4, is that greater or equal to 6? Well, let's see. Negative 12 plus 4, and then we have negative 8. That is definitely greater than 6 because the absolute value of negative 8 is 8, and that's greater than 6. And even if you use negative 5, because remember this isn't equals 2, the absolute value of 2 times negative 5 plus 4 is greater than or equal to 6, question mark because you're still solving. Negative 10 plus 4 is greater than or equal to 6. Negative 6 is greater than or equal to 6, and that checks out. So yeah, that checks out. Now on the other side, let's say I took something like, I don't know, x x equals 2. 2 times 2 plus 4, is that greater than or equal to, oh wait, hold on. Let's see. Yeah, because this is our original solution. I just want to make sure for a minute I wasn't, yeah, okay. Is this greater than or equal to 6? Ugh. Doesn't hurt to check yourself. 2 times 2 is 4, plus 4, greater than or equal to 6. That's 8, which is greater than or equal to 6 because the absolute value of 8 is, of course, 8. And even if we did something like 1, 2, the absolute value of 2 times 1 plus 4, is that greater than or equal to 6? Well, 2 times 1 is 2, plus 4, greater than or equal to 6. Really got to remember the question marks because we're still solving for crying out loud. The absolute value of 6 is greater than or equal to 6, and of course that is true as well. So therefore, this is the set of solutions that checks out. So this is how you would write your solution. X is less than or equal to -5, or x is greater than 1. The reason you can't put them together like we did with the and inequalities is because that wouldn't work. You can't say something is less than -5 and greater than 1. Therefore, they have to be separate, and we say or. Okay, or. And before we wrap up this video, I want to do a quick recap on absolute value equations just to make sure we're all on the same page as far as the different kinds and the different kinds of solutions. So as a recap, the trick is it's all about the distance from 0. So no matter what we go over, remember that absolute value equations, you're talking about how far something is from 0. Enough said. So here's the recap. First, we have the form, the absolute value of x is equal to a. So what this means is the distance from x to 0 is a units, okay? So your solutions are going to look like this. So you're going to have -a and you're going to have positive a, okay? That's pretty straightforward. Next we have the absolute value of x is less than a, or, you know, the absolute value of x is less than or equal to a. So what this means is the distance from x to 0 is going to be less than a units, or less than or equal to, in which case the